what does this mean? Excellent question. To find the force between two objects, we use the universal gravitational force formula. In the universal gravitational force formula, we need to plug in the gravity times the mass of the first object times the mass of the second object divided by the distance squared.
Okay, so let's say we wanted to find the force between the Earth and the Sun, and the distance between them was 637 times 10 to the 6th. What we do is you just take the gravitational force formula here, and we just plug all the numbers in. So then you get this giant equation, as you can see right here. And then what you do is you separate all the numbers. So you separate all these decimals of 6.67 and 5.98 and this and that, and you put that on one side, and then you take all the 10 to the whatever powers there's here, and you put that on another side. And so then you multiply all this together, or you do all that, you work that out, and then you work all this out just by adding all of the powers that 10 is to, and then you get 590 times 10 to 10 squared, and that, no, 5.90, my apologies, times 10 squared, and that gives you 590 newtons.
I will be explaining types with this diagram. This is the sun, the earth, and the moon. Side A of the earth is closer to the moon, and since we know that the force is inversely proportional to the distance, we know that D, since it's a small distance, D is small and the force is large, while in side B, compared to the moon, the distance is larger and the force is smaller. And we're just going to plug in some random numbers to understand why tides work the way they do. And so side A, it's going to have 25 newtons of force. The middle of the earth is going to have 15 newtons, and side B is going to have 5 newtons. Now we are going to get rid of the 15 and just subtract it from both sides of the earth. So 25 minus 15 gives me 10 newtons for side A, and for side B, 5 minus 15 is negative 10. Now it's not a negative number, it's actually going in the opposite direction, which creates a bulge around the earth, and on each end of the bulge it's going to be at a high tide.